said when you try to dissolve a particular salt, break the lattice, separate the ions, and once those ions are separate, that means gaseous ions, they will get surrounded by water molecule and they will become aqueous ions. So 2 steps are involved. That's enthalpy change of solution. Okay, so break the lattice and get the ions mixed with water to form aqueous ions. So there's going to be a group 2 question related to group 2. Okay, but we're going to do it over here because there's not much in group 2 that you have to study anyways. So we're going to do that over here. And it's a very typical question which almost comes in all paper, all exams. Okay? Remember, it's a 100-mark paper. So what happens is some questions, they just come in every paper because it's a 100-mark, it's a big paper. So what they don't have a lot of options for questions. Every time they have to make a lot of questions for that paper. So some questions are kind of repeated every time. Now, and it's this question, which is that if you look at the solubilities of let's sulfates, let's talk about sulfates first. MgSO4, you got CSO4, you got what's after that? It's BaSO4, is I think SrSO4, strontium sulfate, and then you've got barium sulfate. Now these 4, what happens is that the solubility decreases down the group in group 2. So solubility of sulfates so that decreases down the group in group 2. So the question is, why does it decrease? So they're looking for an explanation. It's usually a 4-mark question, a 3 or 4-mark question. So you got a big why. Why does this happen? Okay, that's the question. And you have to explain that. So what happens is, let's take MgSO4. This is the solubility. This is how the solubility is going to work. You got crystals of MgSO4 that's solid. You mix it in water, and the ions are going to dissociate. And when they dissociate, they will become Mg2 plus aqueous and SO4 2 minus aqueous. Okay? So that's your enthalpy change of solution. Now, if the solubility decreases down the group, right? What does that mean? Enthalpy of solution, is it becoming endothermic or is it becoming exothermic down the group? I mean, it's becoming harder to dissolve. So it's MgSO4 turning into aqueous ions, BaSO4 turning into aqueous ions. So is the enthalpy of solution kya hoga? Is it becoming endothermic down the group or exothermic down the group? Endo, क्योंकि मुश्किल हो रहा है ना, it's becoming harder to resolve, right? So that means more energy is needed to, remember, endothermic reactions are less feasible. If something is endothermic, then it's probably not going to happen because it needs energy, right? So enthalpy of solution is becoming more endothermic. That's the first thing down the group. Okay, if I do it for BaSO4, write the same thing with BaSO4, a lot harder to resolve. That means it's more endothermic. Okay, that's the first point. So delta H solution, it becomes more endothermic down the group. ये सारा वो clear, Lisha, है ना? Is this clear? बाकियों clear है? Haseeb?
Yes, sir.
I said it becomes more endothermic down the group. You remember that gets you 1 mark. When you dissolve a sulfate, first thing, you would have to break the lattice. So that's the negative or the opposite of lattice energy. That's you're breaking the lattice. That's an endothermic step. So this first thing is endothermic. You don't ignore this negative sign because that is negative because of the definition, because you're going in the opposite direction of lattice energy. So That's why it's negative. Otherwise, this value is actually positive. Anyways, the bonds are going to break, gaseous ions are going to be produced. And once those gaseous ions are produced, they get surrounded by water and they form aqueous ions. And that's your enthalpy change of hydration, which is exothermic because bonds are getting formed. Because in this case, bonds are getting formed with water molecules. So that part is exothermic. So one part is endo, the other part is exo. You break the lattice and then gaseous ions, aqueous, they turn into aqueous ions and bonds are formed. Now, down the group, calcium sulfate, same cycle, strontium sulfate, barium sulfate. Now down the group, let's focus on this. Down the group, is it going to be easier to break the lattice or more difficult to break the lattice? Like if it had been BaSO4, would it be easier or would it be more difficult? Okay, if I draw the same cycle for BaSO4, remember Ba is a bigger ion. It's going to be easier. Okay, Ba is a bigger ion. Bigger ions, remember, bigger ions, bigger atoms, they always make weaker bonds. So BaSO4 ka jo lattice hoga, that's going to be a lot weaker. So down the group, remember this. What happens is, so down the group, ionic radius increases. That means lesser charge density. It's bigger ions. So ionic radius decreases and increases. Hence, it's going to be a weaker lattice, which is easier to break. So lattice energy, it decreases. Why? Because bigger ions make weaker lattice. ठीक है, ये सारा clear है कि this is going to decrease. Both of them would actually decrease because bigger ions will also make weaker bonds with water as well. ठीक है, you got bigger ions, so down the group ionic radius increases, so lattice energy तो यहाँ पे both होना चाहिए, ठीक है? So lattice energy and enthalpy change of hydration. So I'm going to just okay, just 1 second. Let's go to the side पे करें. So lattice energy and enthalpy change of hydration, they both decrease. So bigger ions are going to make the bigger ions are going to make weaker lattice, and they would also make weaker bonds with water as well. Right, so both of these values are going to decrease. So you clear at this part. Okay, right now what's happening is that so is this clear, this part? Yes or no? Is this clear? Seep, Shian,
Yes, sir.
Okay. So now I'm going to write the answer. Why is the sulfate, why does the solubility of sulfate decreases down group 2? So I'm going to write the answer now. Okay, so the first statement is this one. That's the one that you're going to make, which is so I'm going to copy that, and so enthalpy of solution becomes more endothermic down the group. So that's the first statement. The second statement is this one, that down the group so that's the exact second statement. Now the question is, Remember, this is the statement: enthalpy of solution becomes more endothermic down the group. Why? Because down the group ionic radius increases. So lattice energy and enthalpy of hydration, they both decrease. Bigger ions are going to make weaker lattices, right? So if it's becoming overall, if enthalpy of solution, now to focus on this, if enthalpy of solution is becoming more endothermic, focus on this one, and both of them are decreasing. The endo part is decreasing and the exo part is also decreasing. But in relative sense, which one is becoming bigger in size, endo or exo? What's happening to enthalpy of solution? It's becoming more endothermic, right? So enthalpy of solution is becoming more endothermic. It's becoming harder to dissolve, right? So both of these values are decreasing, but the endo part is still relatively bigger compared to the exo part. Is that clear? You clear about?
Yes, sir.
That's why the enthalpy of solution overall comes out to be endothermic, because the endo part is bigger compared to the exo part. So the last statement is that even though both of them is decreasing, this term is decreasing and this term is also decreasing, bigger ions are going to form weaker lattices. It's going to become easy to break them, but they're also going to form weaker bonds as well. So both of these values are going to decrease, but the endotherm. So the last statement would be that the lattice energy decreases less, or it's bigger compared to the part. The lattice energy decreases less compared to delta H hydration. So that's the reason why it's becoming more endothermic. So I'm going to explain this one more time. Sulfates, they become less soluble down the group. That means this thing becomes more and more endothermic. It becomes harder to dissolve it. DSO4 hota na, it would be very endothermic. So when you're moving down the group, it's becoming more endothermic, right? But down the group, you've got bigger ions. So this is decreasing, lattice energy is decreasing, and hydration, both are decreasing. But since this is becoming more endothermic, the endothermic term is going to be bigger compared to the exothermic. So that's your 4-mark answer for this. That enthalpy of solution becomes more endothermic down the group. Down the group, ionic radius increases, so lattice energy decreases, and hydration both decrease. But lattice energy decreases less compared to enthalpy change of hydration. That's why overall it's endothermic. Okay, that's the answer to this one. You clear, Saurabh? Is this clear? Okay, just remember that it's just a 4-mark question. It's always the same question. It's harder to actually think about it when you have to derive it. It's much easier if you just memorize it. Like this question very often comes almost in all papers. So you just memorize this, that. And then there's the other one, which is for hydroxides. Now for hydroxides, the answer would be slightly different. Because hydroxides में उल्टा हो रहा है. What happens in hydroxides is that the opposite happens, that the enthalpy, that it becomes more soluble down the group. Like MgOH2 is insoluble, and you got you got CaOH2, you got SrOH2, and you got BaOH2. Now over here, the solubility is the opposite. It's they become more soluble down the group. So they become more soluble. So if they ask you why this happens, so the answer to this one is going to be the exact opposite, that they're becoming more soluble. That means enthalpy of solution is becoming more exothermic down the group. That's the first line. Okay, so everything, I'll just copy that. Everything would be exactly the same, except some words would change. So copy the whole thing and I saw this one. I would have to change this to I would have to change this to exothermic. That's it. The rest applies. Down the group, ionic radius increases. So hydroxides ka jo cycle hoga, that would be similar. It's break the lattice, form bonds with the water molecules, become aqueous, right? So this statement would still apply, that the ionic radius would be bigger. So this statement over here would still be true. Down the group, the ionic radius increases. So breaking the lattice and forming bonds with water, they both are going to decrease. The energy values would decrease. But since it's becoming more exothermic, so the exothermic term is going to be relatively bigger compared to the lattice energy. So lattice energy would decrease more compared to the exothermic part. So in this case, last line change can even decreases. Instead of less, I'll make it more compared to enthalpy of hydration. That's why it's becoming exothermic. That now lattice energy, the endothermic part, it's decreasing more compared to the exothermic part. ठीक है, तो बल्कि लिख भी देते हैं इनमें कि breaking the lattice, that's your endothermic part, and forming bonds with water, that's your bond formation, that's your exothermic part. So since it's becoming more endothermic, so it's becoming more exothermic, that indicates that the exothermic is bigger compared to the endothermic. Is this clear? I mean, are these two answers clear to everyone?
Yes, sir.
So now I can go over this again. I mean, this could be slightly confusing, but I'll actually go over this once more. Okay. When you want to dissolve something, break the lattice, pani ke saath, water ke saath, you make bonds with water, right? Exothermic, endothermic, enthalpy solution. So for sulfates, it becomes less soluble. That means it's becoming more endothermic. So if it's becoming more endothermic, the endothermic part is bigger compared to the exothermic part. So that's why it's becoming more endothermic down the globe. So in that case, you're going to write that the lattice energy decreases less, the endothermic part decreases less compared to the exothermic part. The endothermic part is bigger compared to the exothermic part. और दूसरे का तो उल्टा होगा, ठीक है? अच्छा, just remember you'll pretty much get the same question and you'll pretty much write the same exact answer to this. So I can just show you some questions. 1 second. उसी worksheet में होगा जो I sent it last time in the group. That's somewhere energetics. Once again, this one. I just ignored 2014. It's not actually 2014. These are latest papers. So now you'll see questions. For example, this one. It's a 3-mark question. Describe, explain how the solubility of the sulfates of group 2 elements, they vary down the group. So 1 mark would be for solubility decreases down the group. Then you're going to write the whole thing, which is that why does it decrease? The ionic radius increases. So if it increases, what happens? Both lattice energy and delta H hydration, they decrease. And so both of them, they decrease. But solvent decreases, that means it's becoming endothermic. So the endothermic part, which is the lattice energy, decreases less. Decreases less compared to delta H hydration, which is the exothermic part, which makes enthalpy of solution endothermic down the group. So you can write more endothermic or less exothermic. And that's it, the same answer, just repeat that, okay? And it's going to be a typical question. They'll just ask you the same exact question. And there'll be other questions as well. Start can be over just a second. You can have same one, group 2 hydroxides, 3 marks. State explain the trend. I just get less endothermic down the group. They've already stated that. So you have to write the rest of the part. Okay, that's 3 marks. So you're going to write the same thing, that exact same thing, just repeat it. Over here, they've given the cycle as well. So we'll try and do this question. As a CH3N2 with water, so construct an equation. Let's try and do this question. It reacts as now. This pretty much ends the topic. TK, we're done with the topics. We'll just do a couple of questions. Tomorrow we'll start with a new topic. TK, we're done with entropy. We're done with Born-Haber cycle, and we're done with this hydration cycle. Anyways, CH3N2. So it reacts with water to form a white. So it's reacting with water to form a white precipitate suspended in an alkaline solution. So that's probably going to be calcium hydroxide. White precipitate, it's not very soluble. And the oxidation number of nitrogen does not change. So what do you think is the other thing that's formed? So he's saying that the oxidation number of nitrogen does not change. What's the oxidation number of nitrogen over here? What's the number over here? Just a second. Okay, the -3, right? Yes. So which other compound do you think N has a -3 charge on it? Oxidation state, that's probably going to be NH3, right? Is that clear? You can balance this out. It's 3 and 2 N's, and I don't know how many water. That's 6 water, 12 hydrogens. That's 6 and 6. Yes. So Baki or trend wala, that's the same question, exact same question. You're going to answer it the same way. Now over here, he's drawn the same cycle. It's aqueous science, ionic solid. Now ionic solid to aqueous science, that's your enthalpy change of. I said that's 1 second. I said that's your enthalpy change of solution. I said remember the cycle could be made in any, like you can sort of flip it around, right? So ionic solid to aqueous science, that's enthalpy of solution. What is this part? Or arrow bhi laga lete hain, that's ionic solid to gaseous science. What is that? Or gaseous science to ionic solid. What is that? ये वाला path क्या है? Alicia, that's lattice energy, right? This direction is lattice energy. Gaseous ions combining to form the ionic solid, that's lattice energy. If you go the other way around, that's minus lattice energy. Gaseous ions to aqueous ions, that's enthalpy change of hydration. And it's this arrow, right? In this direction. So that's this one. Same question exactly. Describe and explain. Now it's a 4-mark question. Describe and explain the variation in the solubility of the hydroxides of the group 2 elements. Okay, down the group. As this guy, I'll also quickly open. summer 17, 971, 1 second. Seventeen four one. That's another same question. Solubility of hydroxides, it increases down the group. So that means enthalpy of solution is becoming more exothermic. Down the group, the ionic radius increases, so both lattice energy and enthalpy of hydration, they decrease, but since it's becoming more soluble, it's becoming more exothermic, that means lattice energy decreases more compared to the hydration enthalpy. You get the same exact answer that's given over here for 4 mark. So it's again a typical question that comes very often. So लेकिन वो just wanted to, as a longer answer, it's always better to actually check the at least market scheme one time. So the exact same description that's given over here. Increases down the group, both decrease. Enthalpy, lattice enthalpy decreases more. We've talked about then enthalpy of hydration and becomes more exothermic. They didn't give any marks for the size of the ion part, but otherwise everything else was there. Okay, so the rest of the answer was all there. So okay, let's try and do this question. कि अगला टॉपिक कल ही स्टार्ट करेंगे. We'll just do more questions. Now this one, reaction 1 occurs when CO2 is bubbled through. So there's this reaction number 1. Use the data in the table to calculate the standard enthalpy change for reaction number 1. This one. Now what information is given? This information is given. Okay. Now I told you one thing, that they'll try to confuse you with this. Remember, barium hydroxide aqueous is the same as barium ions aqueous and 2 OH ions aqueous. Do you get this one? Make sure you remember this. Barium hydroxide aqueous is the same as this thing. And there's plus CO2, which is gas. So I'm rewriting the equation. And the product is barium carbonate solid, which is BaCO3. Plus H2O, which is a liquid. Now focus on this. Okay, you've got barium ions aqueous, that's enthalpy of formation of everything is given. Okay, when this question came, a lot of people got confused that they said that the enthalpy of formation of barium hydroxide was not given. The only thing was that you just had to write it differently. Barium hydroxide is not given over here, but barium ions aqueous and OH ions aqueous separately is given. Now enthalpy of formation of the reactants and the products is given. So क्या formula use होगा? What do you do in this? How do you calculate the enthalpy change? Can you guys hear me? As a product minus reactants, right? Enthalpy of formation of the products minus the enthalpy of formation of the reactant. So you're going to do that. So your products are these two. So it's minus 12, 16. And water, that's minus 286. You can be very careful with the signs. Minus the reactants. Okay, reaction, they got barium ions, that's minus 538. And you've got what? You've got 2 OH ions, that's minus 230 into 2. And then you got CO2, which is minus 394. Can anyone tell me what's the answer to this one? इसका क्या आ रहा है? Abia, Anna, Alicia, किया किसी ने ऊपर? What's the answer to this? See, minus 110. I'll just check minus 110, right? That's assume we're getting minus 110 kilojoules for that. I'll just double check this. It is minus 110. As the next one, same question again. It's just saying that the standard enthalpy change for reaction 2 is they've already given you the answer to this one. There's this reaction now. The enthalpy change for the reaction number 2 is already given to you. So again, first thing I'm going to rewrite what they're now asking for is use the information to figure out the enthalpy change of formation of HCO3 minus 19. So I'm going to do the same thing. I'm going to rewrite this first. It's going to be BaCO3, which is going to be a solid, plus CO2, which is going to be a gas, plus H2O, which is going to be a liquid. And then there is barium hydrogen carbonate aqueous, which the bottom of aqueous means that they can be written like this. Plus HCO3 minus 1, 2 of them aqueous. Now he's saying isko dhundo, they want to find this one out. They've already given you the answer. So the enthalpies of formation of everything is known. Iska bhi pata hai, that's all of them are already known to you. This is the one that's missing, and the answer is with you as well. So that means minus 26, which is the answer, which is product minus reactants. You're going to do product minus reactants. This is going to be taken as X. We don't know what that is. So the product is 2X. Okay, that's this one unknown. Barium aqueous, it's given in the table over here. That's minus 538. Okay, so that's product minus reactants. Reactants are BaCO3, CO2, and H2O. So BaCO3 minus 1216. And there is CO2 and there's H2O. So CO2 is minus 394. And there is H2O as well, minus 286. So now, so the only difference is you're again doing product minus reactants, but the only thing is that the answer is known. One of the values in between is missing. So you've taken that as X, and you're going to solve for X. Everything was 1 mole. So everything, no numbers need to be multiplied with this. You clear this one? Or agla wala, the next one is going to be done in exactly the same way. You can just quickly go through this. Again, write it in aqueous dissociated form. So, and this one also in aqueous dissociated form. So do that as well. We're done with energetics. There's nothing pretty much left. We're done with all of them. All you have to do now is just practice more questions. We did practice a lot of questions, but try and go through. This worksheet, specifically the one that I sent at the end, it doesn't really have Born neighbor cycle questions. Okay, that was another worksheet that I sent you. So these are more like generic questions, and a lot of them would be kind of just product minus reactants and reactant minus products. बीच बीच में वो enthalpy of hydration solution would come in. So try and go through questions from this worksheet as well. So ठीक है, any कल फिर कंटिन्यू करते हैं. We'll start a new topic. ठीक है, tomorrow. So कोई क्वेश्चन तो नहीं है किसी का? चले, okay everyone. Take care, love. I'll share the video. ठीक है, so probably by in 2-3 hours.